Chapter 6, Unit 1. We're going to talk about probability and how it relates to statistics. So say that you have a jar and it has 50 red marbles and 50 green marbles. You're going to choose a single marble. So the jar of marbles is the population of all marbles. The single marble selected is the sample. And you basically have a 50-50 chance of getting either color because there's the same amount of red marbles as there is green marbles. So you have another jar. It has 90 red marbles and 10 green marbles. By knowing the makeup of the population, we can determine the probability of obtaining specific samples. In this case, there's a much higher probability of selecting a red marble from jar 2, since jar 2 has 90% red marbles and only 10% green marbles. The goal of inferential statistics is to begin with a sample and then answer a general question about the population. So let's talk about reversing that probability relationship. Suppose you had a sample of 4 marbles and they're all red. Which jar would you guess the marbles came from, jar 1 or jar 2? Well, there's a low probability they came from jar 1, and there's a high probability they came from jar 2, because if you got all 4 red marbles, jar 2 has many, many more red marbles than jar 1. So the decision is that you believe they came from jar 2. Not that it's impossible that all 4 marbles came from jar 1, but it's just kind of unlikely. So this demonstrates the uncertainty that we have in inferential statistics, but they're our best guess for what is happening in a population using a sample. So here's an example. Suppose a psychologist gives an anxiety questionnaire to a sample of students during final exams and obtains a sample mean of 20. Based on this result, we can conclude that the sample is more likely to have come from a population with a mean of 20 than from a population with a mean that is not anywhere near 20. So our basic assumption is that anytime you have a sample mean, we're going to assume that the population mean is pretty much the same as what we have for the sample mean. It's just a basic assumption we make in statistics. So let's talk about defining probability in statistics. So the probability for any specific outcome is defined as a fraction or a portion of all the possible outcomes. So if the outcomes are identified as outcome A, B, C, D, and so on, then the probability of choosing A is the number of outcomes classified as A divided by the total number of possible outcomes. So here's an example. Select a random card from a deck of 52 cards. The probability of selecting the King of Hearts is P equals 1 over 52 because there's only one King of Hearts and there's 52 cards. So the probability of selecting an ace would be P equals 4 over 52 because there are 4 aces in the deck out of 52 cards. So typically we use proportions to summarize previous observations, and probability is what we use to predict future uncertain outcomes. Let's talk about probability values. Let's say that we are going to select a random card, and we want to know the probability of randomly selecting a spade out of the entire deck of cards. Well, we know that 1/4 of the cards are spades, so that means 13 out of that 52 cards are spades, right? So that's 1 out of 4. You could also write it as 0.25 or 25%. The probability of tossing a coin and getting heads would be the probability of heads is equal to 1 out of 2. Oh, 50-50 chance, right? 50% chance it's going to be heads, 50% is going to be tails, or you could write it as 0.50. Probabilities are most often expressed as decimals, but really any of these forms is acceptable. Typically in this class, we're going to express probabilities as 4 decimal places. So for the first one, we would have said the probability of spades is 0.2500. And for the second example, tossing a coin, we would have said the probability of heads is equal to 0.5000. So probabilities can range from 0 to 1 in terms of decimal value, or 0% to 100%. So here's an example. You have a jar of 10 white marbles. The probability of randomly selecting another color would be 0 out of 10, or 0%. there's no chance at all you can select a different color because all the marbles are white. And then let's look at the probability of selecting a white marble. This would be, the probability of a white marble would be 10 out of 10 because there are 10 white marbles in a jar of 10 marbles. So the probability would be 1. Or when we talk about decimals, we would say 1.0000 or 100%. You're definitely going to get a white marble. Let's talk about random sampling. So random sampling requires that each individual in the population has an equal chance of being selected. So you start with a population and you sample it and you get a sample for your study, right? Well, a sample that's obtained in this process of everyone having an equal chance of being selected is called a simple random sample. So random sampling requires also that if more than one individual is being selected, the probabilities must stay constant from one selection to the next. This is really big. This is hard for people to understand. This is called independent random sampling, and we typically just call it random sampling. These are the two rules for random sampling. So selecting names from a class one at a time will not be random sampling because everybody's name doesn't go back into the pot to be selected a second time. For random sampling, you have to go back into the pot. So here's an example of that's not random sampling. Probability of drawing a jack of diamonds for the first draw from a deck of cards is 1 out of 52. If you did not draw the jack of diamonds and you draw again, your odds are no longer out of 52 since there are only 51 cards left in the deck. So the probability on the second draw is only 1 out of 51. This contradicts random sampling. You have to have out of 52 cards each time. So random sampling with replacement means each individual must be returned to the population before the next selection. This is required for random sampling. So in your deck of cards, if you're looking for the jack of diamonds, if you drew it the first draw and you didn't get it, your probability is 1 out of 52. You have to put the card you did draw back into the deck again, shuffle them back up, and try and draw a second time. Only in that way will you still have 1 out of 52 and where it would be random sampling, okay, with replacement is required. So probability and frequency distributions. Let's say that you're given a population with 10 scores. What is the probability of obtaining an individual with a score greater than 4? Okay, well, we can put it in a histogram if we want to see the scores. So scores greater than 4 would be a score of 5 and 6, right? So the probability of a score greater than 4 would be 2 scores, 5 and 6, 2 out of the total of 10 scores, which would give you 0.2000, or 20% of the scores. And we can define probability as a portion of area of a graph. So here's another example. Find the probability that you obtain an individual with a score less than 5. Well, that would be the other 8 scores that are shown in white on the graph. 8 out of the 10 scores would have a score less than 5. 80%, 0.8000, however you want to see it. I want you to also note that the probabilities for each of the sides of the graph, they're going to add up to 1.00. So you had 20% of the scores on 5 or 6 greater than 5 and 80% of the scores less than 5, the total adds up to 1.00 or 100% of the scores. Learning check problem 1. Go ahead and pause the video, see if you can solve the problem. An introductory psychology class with 44 students has 20 freshmen, 14 sophomores, 2 juniors, and 8 seniors. If one student is randomly selected from this class, what is the probability of getting a sophomore? How many sophomores are in the class would be step 1. Well, there's 14 sophomores. Step 2 would be how many total students are in the class. There are 44. Finally, you can figure your answer. How many sophomores out of how many total students? The answer would be 14 out of 44. Learning check problem 2. Pause the video. A jar contains 10 Snickers bars and 20 Hershey bars. If one candy bar is selected from this jar, what is the probability that it will be a Snickers bar? Step 1, how many Snickers bars are there? There are 10. Step 2, how many total candy bars? There are 30. So the answer would be 10 out of 30, or 1/3, or 0.3333 would be the probability that it will be a Snickers bar. Learning check problem 3. Pause the video, see if you can solve it. Random sampling requires sampling with replacement. What is the goal of sampling with replacement? A, it ensures that every individual has an equal chance of selection. No, that's not the goal of replacement. B, it ensures that the probabilities stay constant from one section to the next. Yes, that is a goal of sampling with replacement. You have to have the same probabilities of obtaining a sample each time. C, it ensures that the same individual is not selected twice. No, that's not true, because if you have sampling with replacement and you put everyone back in the pot, you could actually choose the same person twice. D, all the goals of sampling with replacement. So you can see here that the answer would be B.